Hello my dear students, today in this lecture we will discuss your half yearly examination paper of RBSc board class 12 subject physics. Okay, we will discuss all the questions included in this paper and try to find out the exact solution. Okay, starting from the first part, that is of MCQ pattern multiple choice question. The first question is the path difference equivalent to lambda by 4 phase difference. Actually that should be equal to pi by 4. We have to calculate the value of path difference from phase difference. Okay, if we know the relation is 2 pi is equal to lambda. This is the required relation for first type of question. When the phase difference is 2 pi, then we get a path difference of lambda. From this relation we can get, this is our main formula. From this relation we can pi is equal to lambda upon 2. Now in question we have to calculate the value of pi by 4. So when we put pi by 4, we get lambda upon 8. That is our option number D, lambda by 8. Okay, this is the direct question from the relations of constructive and destructive interference. Now moving to the next question. The resistance of an ideal ammeter should be. The main purpose of ammeter is to measure current. An ideal means perfect, having no losses. So the resistance of an ideal ammeter is always equal to 0. That's why it can measure current accurately. The third question is the basic concept of current. 4 coulomb charge is flowing through a conductor for 2 seconds. So we can simply say there is a relation I is equal to Q upon T. Current is equal to the rate of flow of charge. According to the question, the charge is 4 and the time is given 2. So 4 by 2 is equal to 2 ampere. The 2 ampere is our option number C. See, you can see in this type of MCQ pattern, there is 2 ampere, there is 2 volt. Okay. So when we are in examination notebook, when you are clicking on the answer, you are typing the answer. Be careful for answers. Okay, similar answer can make you confused and you accidentally write the wrong answer. Okay, moving to the next question. Lenz's law is based on the conservation of energy. Okay, Lenz's law consider the energy of consideration. Now at equatorial line of electric dipole, the potential is, we all know, for equatorial line the potential V is equal to 0 for an electric dipole. Moving to the next question, the value of electrical permittivity for E naught. We have to calculate the value of E naught. The value of E naught comes out to be 8.85 into 10 to the power minus 10. Okay. Moving to the next question. The next question is related to alternating current. The question is IRMS. The relation is IRMS is equal to I naught upon root 2. Simple relation, IRMS is equal to I naught upon root 2. In question, the peak value is given as 6 ampere. That means I naught is given as 6 ampere upon root 2. That can simply be written as, the answer is, if we want to solve this, we can write root 2 upon root 2. That means 6 root 2 upon 2. That is 3 root 2. The required answer is 3 root 2, and if we are calculating current, the unit must be ampere. That is option number C. Okay. These all are the MCQ questions in your examination that was simple, formula based, and just application of formula. Moving to the next part, question number 8. The focal length of convex mirror is 20 cm. Its radius of curvature. We know the direct relation between radius and focal length is R is equal to how many times? 2 times of F. The F is 20 cm. So we can write 20 into 20, that is equal to 40 cm. That is our required option number D. Okay. Moving to the next part, the correct relation for de Broglie wavelength. Okay. The correct relation for de Broglie wavelength says lambda is equal to H upon P. This is first formula. Lambda is equal to H upon P. And if we substitute the value of other formula comes out to be H upon MV. This is other formula. Okay. So by observation of options, we can say the first relation is lambda is inversely proportional to P. And if we move further, we can also say lambda is inversely proportional to M. So both the options are correct. If you have take lambda is inversely proportional to P, you are correct, and if you say lambda is inversely proportional to M, you are also correct. But in comparison of both, the more correctness is of option number C. Okay, moving to the next questions of MCQ type. in the lowest energy level of hydrogen atom, the angular momentum of electron is. As we all know, the formula for angular momentum is given by mvr is equal to nh upon 2 pi. Okay, mvr is the value of angular momentum, nh upon 2 pi. For lowest energy level, we put n equal to 1. So the result comes out to be h upon 2 pi. Results comes out to be h upon 2 pi, which is our required option number C. So this is a complete solutions of MCQs which are directly based on the application of formula. Moving to the next part, Phillips, the question number first. The intensity of electric field inside a uniformly charged spherical shell is, suppose we are provided with an uniformly first question of Phillips. Now we discuss Phillips. First question is uniformly charged spherical shell. This is suppose a spherical shell having radius capital R and it is uniformly charged. This is one of the common MCQs and one of the common Phillips for all examination. What will be the value of electric potential and electric field? Okay, so as we all know, electric field inside is always 0 and electric potential is same everywhere. So in question, what is the condition? The intensity of electric field inside is always equal to 0. Okay, the next question number 2, AC generator converts. What is the main mechanism of AC generator? It converts mechanical energy into electrical energy. Okay, moving to the next question. The coefficient of self-inductance is. The coefficient of self-inductance is, as we all know, self-inductance is denoted by L and we just have to denote the coefficient is always denoted by L. For mutual inductance it is M, and the relations comes out to be, for third question, the relations comes out to be L is equal to phi I. This is the required relation. L is equal to phi I. Okay, L is known as the self-inductance. For fourth question, all the nuclei with same mass number. Okay, if one thing mass number and other is atomic mass. If the mass number is same means having isobars, and same atomic number means isotopes. Okay. Fifth question is, sources of light having a constant phase difference are always known as, what name we provide? We known as coherent sources. When you have discussed the topic of interference, you might have observed that for interference the sources must be coherent sources. Sixth question, unit of magnetic flux is, it is Weber. So the answer for sixth is Weber. Flux is always measured in Weber. Okay. Moving to the next question, does the resistivity of conductor increases or decreases with? Okay. So for metals or conductors, we always know there is a positive value of alpha. So the resistivity and temperature have a positive relation. Rho and T have a positive relation. Okay, positive relation means if T increases, then rho also increases. So for this type of answer, the seventh answer is increases. We simply have to write increases. Okay. Eighth question is, transformer worked on the principle of. The transformer worked on the principle of which principle? Mutual induction. Mutual induction. Or we can say it is based on the Faraday's laws of mutual induction. Both are correct option. So for 8th MCQ, for 8th type of Phillips, the correct answer is mutual induction. Okay. This comes to the end of question number 2, that is related to Phillips. Now moving to the next part, that is our very short answers. The first question in the very short is, what are diamagnetic substance? Give one example. Okay, the magnetic material are characterized into 3 parts. The first part is diamagnetic, other is paramagnetic, and third is ferromagnetic. Okay, di, para, ferro is a short trick. Diamagnetic are the substance which are weakly attracted toward the magnetic field. Okay, para are slightly attracted and ferro are mostly attracted to the magnetic field. Di, para, ferro. Okay. Now question is, what are diamagnetic substance? And give an example of examples of diamagnetic are bismuth, Au, water. These are all the examples of diamagnetic substance. Okay. Moving to the next questions. What do you mean by Biot-Savart law? Okay, as we all know, the Biot-Savart law is related to magnetic field, and it gives the value of magnetic field due to current carrying element. Okay, the value of magnetic field due to current carrying element, and the formula comes out to be B is equal to mu naught upon 4 pi IDL sin theta upon R square. This is the required formula for Biot-Savart law, and the current carrying element is IDL. Okay, simply what is Biot-Savart law? It is used to find the magnetic field due to which current carrying element IDL. Okay, moving to the next question. The next question is write the Gauss law for magnetism. This is slightly tricky question and kind of JEE NEET question, target question. Generally the Gauss law for electrostatics is well known to students, but in this examination it is asked about the Gauss law for magnetism. So for the Gauss law of magnetism, we simply write the line integral of B dot ds is always equal to 0. This is a required Gauss law for magnetism. In electricity we use E term, okay, for magnetism we use B term, and this simply says the incoming magnetic field is always equal to outgoing. That means the magnetic field inside any surface is equal to 0. This is question asked in NEET 2022 examination also. What is the correct sequence of Gauss law for magnetism? Moving to the next part, question number 4, state the Malus law. As you all know, the Malus law you have studied in your topic wave optics. Malus law is nothing. It is the relation of intensity of light I is equal to I naught square cos square theta, where angle theta is between the angle polarizer and analyzer. Okay, you have just discussed in the topic of wave optics. Moving to the next part, the next question is define doping. Doping is discussed in the topic of semiconductor. Means doping simply means the original semiconductor or the pure semiconductor are called intrinsic. Intrinsic semiconductor are pure, and when we add impurities, so intrinsic converted into extrinsic. This simply process is known as doping. The process of adding impurity to which intrinsic semiconductor, intrinsic means pure, so after adding impurities they become impure, and this complete process is known as doping, and the element which is added is known as dopant. There are two types of dopant. For N type there is different, for P type that is different. Okay, for P type we are using trivalent, for N type we are using pentavalent impurities. Moving to the next question, which radiation is used to destroy bacteria? You have discussed in the spectrum table. For destroying of bacteria, for sterilization we are using UV rays. Okay, next question is stopping potential. As the name suggests, it is the working is same as the name. Stopping potential is denoted as Vs. It is actually the potential of negative potential. Which potential? Negative potential, which stop which current? Photoelectric current, which stop the photoelectric current. So stopping potential is the negative potential which stop the photoelectric current, and the relation is given by kinetic energy is equal to EVS, where Vs denotes the stopping potential. Kinetic energy has its maximum value, half V maximum whole square is equal to EVS. Okay, this is a required relation for stopping potential. This is observed during your photoelectric experiment theory. Okay, this comes to the end of your section of 1 marks question, very short mark question. Now moving to the next part, that is our section B. Section B has questions of short types answer. Okay, so we will discuss one by one. Fourth question is related to a numerical theory of solenoid. As we all know, solenoid has a magnetic field B is equal to mu naught small Ni, where small n can be written as capital N upon L into I. Now comes to the question, a solenoid of length how many? 0.5 meter, radius 1 centimeter, number of turns 500, carries a current of 5 ampere. What is the magnitude of magnetic field? So the magnitude of magnetic field is given by this relation. As we all know, value of mu naught is 4 pi into 10 raised to power minus 7, and capital N is given as 500, capital I current is 5 ampere, and L, the length is given as 0.5 meter. On solution, you get the required answer. Okay, just apply the simple mathematics and you will get the answer. Moving to the next part, the next question is related to current electricity. Write Kirchhoff junction rule. Kirchhoff junction rule is the other name for Kirchhoff current rule. The algebraic sum of current entering at any node must be equal to current leaving the node. So we take the current, suppose this is node A, this is node B and this is node C. At A, the incoming current is always taken as positive and the outgoing current is always taken as negative. So at A, what are the two incoming current? 2 and 2.5. So we are adding 2 and 2.5, we get 4.5 ampere. Okay. Out of 4.5, 1 ampere is outgoing. So the remaining is 3.5. And out of 3.5, the outgoing is 1.5. So we subtract 3.5 minus 1.5, we get 2 ampere. This is the required solution of the question number 5. Okay. Moving to the next question. Write the Einstein photoelectric equation. Explain the result of photoelectric effect on this equation. We have to explain the Einstein equation for photoelectric effect. So simply the relation is, we get the relation is h nu minus nu naught is equal to kinetic energy. This is the required relation for Einstein. Kinetic energy is equal to h nu minus nu naught, where h is Planck constant, nu is frequency and nu naught is threshold frequency. You just have to explain this and draw the required graph. Okay. Moving to the next part, question number 7. Question number 7 is related to ray optics. That is the question from your RBSc examination 2012. Same question have been asked in the RBSc examination. The question says, an object is placed at a distance of this and this in front of concave mirror, radius of curvature is this. There are two questions. First question says, object is placed, suppose object distance is 10 centimeter. Okay. In other case, the object is placed at u is equal to 5 centimeter. Okay. In front of concave mirror. No, for concave mirror, we know all the values are in the left side of mirror. So left side of mirror, that's why we take u negative and this u is also negative. And the radius of curvature r is equal to 15 centimeter. That is also negative. R is equal to minus 15 centimeter. Okay. In each position, find the position, nature and magnification. Okay. You have to calculate the value of V and you have to calculate the value of M, and on the basis of M you have to predict the nature of image. So we all know for this we are using the mirror formula. For first we have to calculate the focal length. Focal length is equal to R is equal to 2f, f is equal to R upon 2. R upon 2 means you can simply calculate the focal length, and using which formula this question can be solved? Using mirror formula. Mirror formula is nothing but the 1 upon V plus 1 upon U is equal to 1 upon F. This is the required mirror formula. Okay. By just putting the value, you can easily calculate the value of V. Value of V denotes the image parameter. Okay. Image distance. And after calculating V, you are already provided with U. So you can calculate the value of magnification as minus V upon U. So this is the required second part. And after calculating magnification, if the magnification is negative, then you will got a real image. And if the magnification is positive, then image must be virtual. So you can comment on the nature of image also. Okay. This is the required solution of question number 7. Moving to the next part. Write the 3 postulates of Bohr model. There are 3 or 4 postulates. The first postulate is about the atom structure. Second is about the stationary orbit. Electron is always moving in a stationary orbit. Third is the electron will revolve in those orbit having angular momentum is equal to mvr is equal to nh upon 2 pi. And the last condition is the frequency condition. When the electron transit from higher orbit to lower orbit, it always emits energy in the form of photon. So we can write firstly simple is 1 and 2 is simple. Third is related to angular momentum, mvr is equal to nh upon 2 pi. This is quantization condition. And other is last condition is frequency E2 minus E1 is equal to h nu, means E2 is higher energy orbit and E1 is lower energy orbit. Whenever electron transits from higher orbit to lower orbit, it releases energy in the form of photon energy. This is the Bohr model. Next question is nuclear binding energy. As the name suggests, the energy which binds the nucleus, okay, or the energy required to separate the nucleus up to finite distance is called nuclear binding energy. Okay, so as we all know, nuclear binding energy is question number 9. Nuclear binding energy is actually delta m c square. Delta m c square. It is the energy required to separate the nucleus up to finite distance. Delta m, as we all know, is the mass defect. Delta m is the actually mass defect, that is equal to ZMP, total mass of proton, plus NMN, total mass of electron, minus capital M. Capital M is your rest mass or the experimental mass. Okay, by just substituting the value, you can calculate the binding energy. And the other question is related to binding energy per nucleon. Binding energy per nucleus is nothing but the ratio of binding energy upon mass number. Okay, binding energy upon mass number. Okay, moving to the next question, define capacitor. Capacitor is simply arrangement of two plates, one positively charged, other negatively charged, okay, used to store the charge. And explain the principle of capacitor. Principle of capacitor is nothing but the electrostatic induction. How there is a formation of capacitor? We can simply understand in this question. Capacitor has two plates, A and B. Okay, firstly we provide a positive charge. Which charge? Positive charge. So the plate A is positively charged. Okay, now due to the positive charge of plate A, there is a negative charge inside this plate and this is positive charge. This phenomenon is nothing, as you all know, this is actually electrostatic induction. Electrostatic induction. This phenomenon is known as electrostatic induction, in which the charges of opposite polarity are developed on the nearby plate. Now we ground this positive charge to earth, so the remaining structure may be A plate and B plate. It has positive polarity, it has negative polarity. Okay, this is the required diagram of parallel plate capacitor, and in between this blank space there is dielectric. Which material? Dielectric, which is used to separate the both charge plate. Okay, this is the principle of capacitor. Okay, now moving to the next part, write the relation between drift velocity and current. We all know I is equal to, for question number it is 11, I is equal to NEAVD. This is the required relation for drift velocity and current. And if in examination it is asked about the current density, so we can see I upon A is equal to NEVD, and I upon A can be written as J NEVD. This is the previous year questions of your board examination, in which he asked about the current density. Okay, this is the required solution for your section number B. Okay, moving to the next part, in section number C, the question is related to your long answer. The question number 12 is explain the reflection of light by Huygens wave theory. So reflection has two fundamental principles. First is angle of incidence must be equal to what reflection says. Suppose this is a reflecting surface, this is incident, this is normal, this is I, this is R. Okay, the first law for reflection is angle of incidence must be equal to angle of reflection. Another law says the incident ray, reflected ray and the normal must lie in the same plane. You have proved this for the which wavefront also. Okay, moving to the next part. Obtain an expression for pure capacitive circuit, instantaneous value and capacitive reactance. Suppose the value of voltage is E is equal to E naught sine of omega t. This is the value of voltage, and we have to calculate the value for capacitive circuit. For capacitive circuit, I denote current as IC. I is equal to E naught sine of omega t plus pi by 2. So you can simply see the current IC leads the voltage V by which angle? Pi by 2. Okay, you have to derive this relation. Now, what do you mean by the capacitive reactance? Capacitive reactance is denoted by Xc. Xc is equal to 1 upon omega C. Okay, this is the value of capacitive reactance, and omega can be written as 2 pi f. So, the other formula comes out to be this: capacitive reactance in the hindrance offered in the path of current by the capacitive parts of the circuit. Okay, moving to the next question. The next question is for the derivation of Gauss theorem by using for concept of charge wire. So, the value of electric field comes out to be 2k lambda upon r. This is the required formula for question number 14. And the last section discuss about the long question, essay type question. In 15 number question, you have to explain the compound microscope used to magnify image having two lenses, objective lens and the eye lens. You have to derive the relation. And the next question is refraction of light and the refraction for spherical surface. In this derivation, you have to combine the two equations, rarer to denser and denser to rarer, and after combining both the equation, we get the required answer. In 16 long question, what is rectification? Rectification is nothing but the process of conversion of AC to DC, and you have to explain the circuit of half wave rectifier. And the last question is regarding forward biasing and reverse biasing of PN junction diode. Forward biasing simply means connecting positive to positive and negative to negative, and the reverse connection is called reverse biasing, and we have to draw the curve for forward and the reverse. This is all about your essay type question. This comes to an end of your question paper of half yearly. More or less, this is question paper from your almost PYQs, previous year questions of your board examination. So, you can have overview of your final examination from this paper of half yearly. So, practice more and more types of question. Majority of the mistakes are seen in your this type of very short and MCQ pattern. So, I suggest all the students, so be focused on this type of MCQ pattern, Phillips question, because these are the parameters which are responsible for deduction of your marks, because long questions are fixed from every chapter. Long questions are almost fixed. You can have an idea of this question if you have an overview of PYQs. So, practice more and more on this type of question. Okay, thank you.